Hello everyone, this is Siddharthan. In this video, we are going to build a machine learning system that can predict whether a person has diabetes or not. Okay, so we will be using one of the important machine learning algorithms, support vector machine. Okay, so we will do our coding in Python. And first of all, let's try to understand about this problem statement and let's try to understand about this support vector machine algorithm. Then let's get into the coding part. Okay. So first of all, let me explain you about the support vector machine model. So this is one of the important algorithms of supervised learning algorithms. Okay, so in supervised learning, we feed the data to our machine learning model, and the machine learning model learns from the data and its respective labels. Okay, so here the labels are the most important things. So what happens is, in this case, we train our model with several medical information such as the blood glucose level and the insulin level of patients, along with whether the person has diabetes or not. So this act as labels whether that the person is diabetic or non-diabetic. So this will be the label for this case. Okay, so once we feed this data to our support vector machine model, what happens is it tries to plot the data in a graph. Okay, and once it plots the data, it tries to find a hyperplane. So in this image you can see a hyperplane. So what happens is that this hyperplane separates these two data. Okay, so once we feed a new data to this model, so it tries to put that particular data in either of these two groups. Okay, and by that it can predict whether the person will be diabetic or non-diabetic. Okay, so in this case we use several medical informations such as BMI of the patient, their blood glucose level, their insulin level, etc. Okay, so now let's try to understand the workflow for this project. So first of all, we need this diabetes data. Okay, so we will try to train our model with the data and the respective labels. Okay, so before feeding this to our model, so there are a lot of steps in between. So we need to pre-process the data, where we will try to analyze the data, and this data won't be very suitable to feed to the machine learning model, and we need to standardize this data because there are a lot of attributes here, a lot of medical information, and we want all this data to be in the same range. So what we do is we try to standardize all this data so that all this data lies in the same range. So all these things will be done in the data pre-processing step. So once we pre-process the data, we will split the data into training and testing data. Okay, so we train our machine learning model with training data, and then we try to find the accuracy score of our model with the help of test data. Okay, so it tells us how well our model is performing. Okay, so once we split the data into training data and testing data, so we will feed this to a support vector machine model. Okay, so we will be using a classifier model, where this model will classify whether the patient has patient is diabetic or non-diabetic. Okay, so once we have trained it, we have a trained support vector machine classifier. So when we give a new data, so it can now predict whether the patient is diabetic or non-diabetic. So this is the workflow we will be following for this project. Okay, so now let's get into the coding part. So we will be doing it in Google Collaboratory. So in our channel, I have already made a video on how you can access Google Collaboratory from your Google Chrome. So the index of that video is 2.1, and you can search it from there. Okay, first of all. So now we need to import the libraries. So I'll make a text here so that it's clear. Importing the dependencies. Okay. So first let's import NumPy. Import NumPy SMP. Now let's import pandas. So import pandas SPD. Now we need to standardize the data. So for that we need a standardizer function. So from sklearn dot preprocessing imports standard scaler. Okay, so this standard scaler will be used to standardize the data to a common range. Okay, from sklearn dot model selection import train test split. So we will use the train test split function to split our data into training data and test data. Okay, from sklearn import svm. So svm stands for support vector machine. Okay, now we need to import the accuracy score from sklearn dot metrics import accuracy score. Okay, so numpy is used to make numpy arrays. So numpy arrays are very helpful in our processing. And pandas, so pandas is mainly used for creating data frames. Okay, so it is useful to put our data in a nice structured table. Okay, so then we use this standard scaler to standardize our data, and then train test split function is used to split our data into training and test data. And we have of course imported the model support vector machine, and now we have imported accuracy score. So I'll run this. So I'll press shift plus enter. This will run this cell and automatically goes to the next cell. Okay, so now we need to do the data collection part, data collection and analysis. Okay, so I'll upload the data file here. So I'll give the link for this data file in the description of this video, which diabetes.csv. Okay, so this data set is called as PIMA diabetes dataset. So I'll mention it here. So you can also find this dataset in UCI machine learning repository and Kaggle. PIMA diabetes dataset. So you can search in the internet. So you will find these datasets in UCI or Kaggle, as I said. So basically this contains the informations of patient who has diabetes and those who doesn't have diabetes. So it basically contains the data of females. Okay, so there won't be any data for males. So it contains various parameters such as the number of pregnancy they have gone through, their blood glucose level, insulin level, etc. Okay, now let's load this data in this CSV file to a pandas data file. Okay, loading the dataset, the diabetes to a pandas data frame. Okay, so I'll create a variable called as diabetes dataset. So this is called as a variable, and we will store the data frame in this variable. Okay, so sorry, so diabetes dataset is equal to, we need to use the function pd.readCSV. So this will load the CSV, which is a comma separated value, to a pandas data frame. Okay, so I need to copy the path of this file. So go to this folders, and in this options you can give copy path. So once you've copied the path, you can paste it here and run this cell. So you can also run it from pressing this run symbol. Okay, for example, like in some cases you may not sure what does a particular function does. Okay, let's say that you don't know what this pd.readCSV function does. So you can get the explanation for this function by typing this function here. So pd.readCSV and include a question mark with it and run this cell. So you will get this help section where you can see this function and what are the parameters you need to include in this. So you don't need to include all those parameters. So you just need to include the main parameters such as the location of the file and other things. Okay, so you can read why this function is used. So it read a comma separated value file into a data frame. Okay, so you can see the additional information here and you can see the parameters of this function. Okay, so this features is very much helpful for us to understand what does a particular function does. So you just need to mention the function and include a question mark with it. So this is one of the important feature of Google Collaborative, which is very helpful. Okay, now let's try to print the first 5 rows of this data frame. So we can use the function yet for this. So we need to mention this data frame name, which is diabetes dataset. Okay. So printing the first 5 rows of the dataset. Okay. So mention this data frame name, which is diabetes dataset dot date. Okay. Now run this cell. So this will give the first 5 rows of our data frame. Okay, so as I've told you, this data set includes the data for all the females. So in that test case, so you can see the number of pregnancies, the blood glucose level, blood pressure, skin thickness. Okay, so this skin thickness is taken from the triceps. Okay, so this basically tells whether some fat is stored in that particular muscle. Okay, so then we have the serum insulin level. Then we have the body mass index, which is basically calculated by dividing the weight by height squared. Okay, and then we have a diabetes pedigree function, which is basically a number which indicates some diabetic value. Okay, and then we have age, and then we have outcome. Okay, so these are the labels. This outcome part is the label, where 1 represents that the patient is diabetic and 0 represents that the patient is non-diabetic. Okay, so these are the labels. So all these values will be either 1 or 0. So we need to develop a system that can classify this data to either 1 or 0. Okay, now let's try to see the number of rows and columns for this data set. So I hope every one of you knows this feature, but I'm just telling this for new users who are just starting to learn Python. So we use hash in Python to write a command. So if I remove this, the Python will recognize that it is part of the code. So if I include a hash, it assumes that we are writing some comment or some information about what does this code do. Okay, so you can mention some description of what you are going to do by preceding the line with the hash. Okay, so we are going to get the number of rows and columns in this data frame. Number of rows and columns in this data set. Okay, so mention the data frame name diabetes dataset dot shape. Okay, as you can see here, we have 768 rows and 9 columns. Okay, so 768 columns means, 768 rows means we have 768 examples. That means the data is taken from 768 people, and we have 9 columns. These columns represent the features or parameters or attributes. So these are the medical informations that we are going to use for our prediction. Okay, so leave this last column because this is the label, and these 8 are the important features we are going to be needing for our prediction. Okay, now let's get some statistical measures of this data frame. So getting the statistical measures of the data. Okay, so you can use the function describe, and this will give the various statistical measures such as the mean of the data, the standard deviation, percentage, etc. Okay, so it will give all these values for all the seven or 8 columns we have. Okay, so it first count tells the number of data points we have, and mean gives the mean value of all these columns. Okay, for example, this mean gives the mean value of glucose. So we get that the mean value of glucose for all these data is 120, and those kind of statistical measures. Okay, so then we have the standard deviation, the minimum value, 25th percentile, 50th percentile, 75th percentile, and maximum value. So percentile basically means, let's say for example 25 percentile means, so 25 percentage of the value are less than 99, and in the case of blood pressure, 25% of the value are less than 62. So 50 percentile means, so 72 sorry 50 percentage of the value of blood pressure or less than 72. So that is why percentile is used, and it is different from percentage. Okay, so now let's see how many cases are there for diabetic examples and non-diabetic examples. So diabetes data set outcome dot value counts. So this value counts function, so you can see here I have mentioned this outcome here. So basically what happens is it takes this outcome value and checks how many examples are there for this one label and for zero label. Okay, so I'll run this. As you can see here, so we have 500 values for the label 0 for the non-diabetic cases, and we have 268 values for the label 1 for those people who are diabetic. Okay, so the proportion of non-diabetic cases is more in this data set. So this is a pretty smaller data set. So totally we have 768 examples. So typically in a machine learning or deep learning projects and use cases, we generally use thousands and even lakhs of data. Okay, so it depends on the data set that is available for us. So the idea of this use case, this video I'm making, is for you to understand what approach we will take for solving a machine learning project. Okay, so for that purpose this data is sufficient. Okay, now let me make a text here. So we know that the label 0 represents non-diabetic people, so non-diabetic. Okay, and the label 1 represents people with diabetes, so 1 represents diabetic. Okay, now we can try to get the mean for all those value for this label 0 and 1. Diabetes dataset dot group by outcome mean. So this will give the mean value for both these cases. So it calculate these values for all the data set. Let's say for example we have this label 0 and 1, and we get that the mean value for glucose for all those people who are non-diabetic is 109, and the mean value of glucose all those people who are diabetic is 141. So it is obvious that the diabetic people have more glucose level in their blood, right? So and then we have the blood pressure value and all those things. So this difference is very important for us, because this is what the machine learning algorithm will see and detect that if a person has these kind of values, they can be diabetic, or if a person has the value in the range of some other value, like say for example 140 or 150, it can predict that the person has diabetes. Okay, so you can also see the age here. So it is obvious that people with more age are more susceptible to get diabetes. So these are some important insights we can get from this data. Okay, so it's a good practice to always group the data set based on their labels. Now, so what we will do is let's separate this data and label. So we want all this data except this label in one particular location, and we want this label separately. Okay, so I'll create a variable. So I'll make a comment here, separating data and labels. Okay, so I'll create a variable called as x, and we shall store all the data except the labels in this variable x. So diabetes dataset dot drop columns is equal to outcome comma axis. Okay, so axis is equal to 1 and y is equal to diabetes dataset outcome. Okay, so basically what we are trying to do is, so we are taking the variable x and we are dropping a particular column called as output. So we are taking this data frame. So you can see here we have loaded the data frame, sorry, the data set into the data frame called as diabetes data set. So in that I am dropping this particular column. Okay, so that's why I am mentioning that I am going to drop a column, and I'm going to drop the column outcome, and I mentioned here that the axis is equal to 1. Okay, so if you are using this drop function, you need to specify that axis is equal to 1 if you are dropping a column, and you need to specify that the axis is equal to 0 if you are dropping a particular row. Okay, so I am getting this x for all the values except the label, and now I am storing those all the labels in this variable y. Okay, so as you can see here, I am taking this diabetes dataset. I am taking only the outcome column. Okay, and I am storing it in the variable y. So I'll run this. So this will separate the dataset. Now let's try to print x and y. So I'll print x. So as you can see here, we have all the data except the outcome, which is the label. Okay, so as you can see here in the previous data frame, we have outcome and the data together. So you can see here. And now we have separated the data in the variable x. Now let's print y, which contains the labels as either 1 or 0. So 1 represents diabetic patients and 0 represents non-diabetic patients. Okay, so totally we have 768 rows. So you have 767 because in Python the indexing starts from 0. So totally there are 768 rows. Now what we are going to do is standardize the data. Okay, so this is one of the important steps in data pre-processing. Data standardization. Okay, now why we are doing this? You can see here we have number of pregnancy here, glucose value, blood pressure value, BMI, etc. So the range of pregnancies is 1, 2, or 3 in that range, and the glucose level is around hundreds and 150 level, and the blood pressure level is around 60 and 70. BMI is around 25, 30 range. Okay, so if there is a difference in the range of all these values, it will be difficult for our machine learning model to make some prediction. So in most cases, what we will do is we will try to standardize the data in a particular range, and that helps our machine learning model to make better predictions. So that is what we are going to do here. So if you remember, we imported a function called a standard scaler, so we are going to use this function for this purpose. Let me create a variable called a scalar, and let's load that standard scalar function. Standard scalar, you need to include this parenthesis. So this means we are taking one instance of this standard scalar function. So I'll run this. Now we need to fit this data in this scalar. So basically this scalar variable as this standard scalar function. So we need to give standard scalar dot fit x. Okay. So now we need to transform this data. So I'll create another variable called as standardized data is equal to scalar dot transform x. Okay, so basically what we are doing is we are fitting all these inconsistent data with our standard scalar function, and based on that standardization we are transforming all the data to a common range. Okay, so instead of using this fit separately and transform separately, you can also use function like scalar dot fit transforms. So this just fits the data and do the transformation in a single step, whereas we are here we are trying to fit it separately and transform it separately. In both cases it just gives the same values or same result, so you can do any of them. Okay, so this will fit and transform the data so that we get the data in the same range. I'll run this. Okay, now let's try to print this data in the standardized data. Okay, as you can see here, all these values are in the range of 0 and 1. Okay, so this will help our model to make better prediction because all the values are almost in the similar range. Okay, Now we can make this simple by giving this standardized data to the variable again to x. So x is standardized data and y is again the labels, which is diabetes dataset outcome. Actually, we have already done that. There is no need to do this. I'm just doing this so that you can remember that. So we have already did this part here. So as you can see it, but this doesn't make any change. Okay. So we are taking all this standardized data and feeding it to the variable x, and we are getting all these labels. So you can see the column here. So outcome label, and we are storing it in the variable y, and we will use this x and y for training our machine learning model. Okay, so basically x represents the data and y represents the model. Okay, so let's run this. Now let me print x and y. So print x and print y. So now we have all these data in the x and all the labels in y. Okay, now we need to split our data into training data and test data. So train, test, split. So we need to mention four variables here: x train, x test, y train, y test. Okay, so let me first just make the function and I'll explain you what this particular function does. So we have four variables: x train, x test, y train, and y test. Okay, so we can use the function train test split. So you can see here we have imported this function train test split from the module sklearn.model selection. Okay, so train test split, the important attributes are x, y. So x is the data and y is the label, and test size. So I'll give the test size is equal to 0.2. I'll explain all these parameters in a minute. Stratify is equal to y. Random state is equal to 2. Okay. So basically what we are going to do is we are taking four variables. So what these four variables means? So we have x train and x test. So this x, so this x data will be split into two arrays. Okay, so the first one is x train and the second one is x test. So we will train our machine learning model with this x train data, and then once the model is trained, we will try to evaluate our model with the test data. Okay, so you can compare it with this example. Consider that a person is studying for a max exam. Okay, so he is solving several questions in a particular book. Okay, so the questions he is solving for the questions he is practicing is like the training data, and in the exams he will get new questions or different questions that he haven't solved or he hasn't solved. Okay, so these questions are test data. So that is the similar case we have here. So we will train our model with the help of training data, and we will test the model with the help of test data. The idea here is the machine learning model should not see this test data. Okay, so we want our model to make prediction on this unknown data, and we will try to predict its accuracy. Okay, so that is the reasons for having x train and x test. Okay, so this y train represents all the labels for this x train data, and y test represents all the labels which is 1 or 0, which represents diabetic or non-diabetic for this x test data. Okay, so this train test split will function will give us four outputs, and that outputs will be stored as x train, x test, y train, and y test. Okay, and then we are using the attributes here. So x and y, so we need to mention the whole data set here. So the entire data set is given as x and the entire labels are given as y. So from this, the x train, x test, and y train, y test will be splitted, and then here we have the test size is equal to 0.2. So 0.2 represents 20 percentage of data. So this is for mentioning how much percentage of data you want for test data. Okay, so here I'm getting 20 percentage test data. So you can also give zero point 0.1. So if you give zero point 0.1, that means you are having 80 percentage of this entire data as training data, and the 10 percentage or 20 percentage as test data. Okay, and then we are stratifying based on y. Okay, so based on y means, so y basically has the values as either 1 or 0. So we want our data set to be splitted in the same proportion. Okay, so for that purpose we are using the value y, because if we don't mention this, there is a chance that all the cases for diabetic will go to one data frame. Say for example, if we don't include this stratify, all the diabetes cases may go to x train, and all the non-diabetic cases may go to X test. So that is the reason we are using stratify y, to avoid that, where there will be similar proportion of diabetic cases and non-diabetic cases as there in the original data set. So that is the reason for stratifying this. And then we have random state. So random state is like, let's say for example, you are making this similar code and you want to split the data in the same way I did. So in that case you need to mention the number 2. So if I mention the number 1, the splitting of the data will be different. So if you want to replicate that splitting, you can represent 1. This is like an index or a serial number for a particular splitting of data. Okay, so if I'm using 2, and while you are trying this code, if you also use the number 2, so your data set will be splitted in the same way that the data split is splitting for me. Okay, so this is basically for replicating code. Okay, so I'll run this. So this will split our data. Now we can check the shape of our x train x test and the original data set. So the original data set is x, and let's check the shape of x train and x test dot shape. Let's run this. So now you can see here there are totally 768 examples in our original dataset. Out of those, 614 are going to be used for training data, and 154 will be our test data. Okay, so this is a good proportion where we took 20% of the data as test data. Okay, now we are going to train the model. So let me make a text here, training the model. So I create a variable called as classifier. So classifier is equal to, so we are going to use this function svm. So this is used to load our support vector machine. So classifier is equal to svm dot svc. So svc represents support vector classifier, and we need to represent another parameter here, which is kernel. So kernel is equal to linear. So we are going to use a linear model. Okay, so we are using support vector machine classifier, and let me run this. Now this will load the svm model into this variable called as classifier, and now we will fit our training data to this classifier. Okay, training the support vector machine classifier. Okay, so mention this variable, which is classifier dot fit. So this is the training part. Okay, so we have to mention the training data. Here the training data is x train, and the labels for this training data is y train. Okay, so we need to mention both of them here. So x train comma y train. So this basically represents the training data and the label for that training data. Okay, so this is a small data set, hence we don't need much time for training. So if you are using thousands and lakhs of training data, it will take a long time for you to do that training. Okay, so this has trained our machine learning model. Now we can evaluate our model. So basically evaluation is to check how many times our model is predicting correctly. Okay, model evaluation. So we will be finding the accuracy score. So first let's try to find the accuracy score on training data. So we will try to predict all these training data. So we won't give the machine learning model these labels. So we will try to predict the label for all these training data, and we will compare the prediction of our model to the original labels, which is white train, and try to predict the accuracy score. Okay. So accuracy score on the training data. Let's make a variable called as xtrain accuracy. Okay, so xtrain accuracy is equal to classifier dot predict. Okay, so it's not accuracy, so we need to make the predictions. Xtrain prediction classifier dot predict xtrain. So this will basically predict the label for all these xtrain. Okay, so and we are storing all these labels in this xtrain prediction variable. Okay, now we need to find the training data accuracy. Training data accuracy is equal to, so we have imported the function accuracy score here, so we are going to use that. So accuracy score xtrain prediction and the original label, which is void train. So what we are doing is we are using our trained machine learning model. So once we fit our machine learning model here, so our model is trained, and this trained model is stored in the variable classifier. Now we are using that model to predict the labels. Okay, so we are going to predict all the labels for xtrain. So all those predictions made by the model are stored in this variable xtrain prediction. Now we are comparing the prediction of our model, which is stored in this xtrain prediction, with the original labels, that is white train. Okay, so this will give us the accuracy score of our model. Let's try to print this accuracy score. So print accuracy score of the training data. So accuracy score between, if it's above 75, it's pretty good. And in this case, we are using very less number of data. So there is a chance that we may get kind of low accuracy score. Okay, so if your accuracy score is greater than 75, it's pretty good, because you can use other optimization techniques to increase that accuracy score. Okay, so now let's see whether our accuracy score is beyond 75 or it's less than that. Okay, accuracy score on the training data. So let's print it here. So training data accuracy. So as you can see here, our accuracy score is 78.6, which is almost 79, and it is pretty good. So it means out of the 100 predictions, our model is predicting 79 times the correct predictions. Okay. Now we need to find the accuracy score on test data. Okay. So this is the important step, because the model has already seen the training data, because we are training the model basically with the training data, and it doesn't make sense if we only evaluate our model based on that. So we need to use the model to predict some unknown data. So it tells us that how well our model is performing. Okay, so it's similar to the exam case, where the student is exposed to questions to which they are, not practiced. Okay, so now let's try to find the accuracy score on the test data. So let me copy this here and just change this to test data. So X test prediction. Now we need to specify our test data. So this will be test data accuracy. We need to change all these. So we are taking this X test and Y test. So you can see here that we we have split the data into xtrain and xtest, ytrain and ytest. So we have trained our model with the help of this xtrain data. Now we need to test our data with the help of this xtest. Okay, so that is what I am doing here. Now let's try to find the accuracy score on test data. And again we need to print the accuracy score, so this time for test data. So accuracy score of the training of the test data. So I am just going to print this value here. Okay, test data accuracy. So the accuracy score is 77, which is again pretty good for this small amount of data. Okay, so we are getting the accuracy score as 78 for training data and the accuracy score for test data as a 77. Okay, so it is a good evidence that the model has not overtrained. Okay, so overtraining represents the model just trains a lot on the training data that it cannot perform well on the test data. So in that case, the training data accuracy will be very high and the test data accuracy will be very low. So this concept is known as overfitting. Okay, so we will be dealing all of those theories and concepts in the later module of our course. Okay, and also we will be seeing in detail about all those model examples, the support vector machine, logistic regression, all those models in detail in the later videos. Okay, so we have found the accuracy score for training and test data as of now. Now we need to make a predictive system that can predict whether a person has diabetes or not given all these data. So we have all these data as pregnancy, glucose, blood pressure level, skin thickness, insulin, BMI, and diabetes pedigree function. So we have all these data, right? Once we give all these data, our machine learning model has to predict whether that person has diabetes or not. Now we are going to build that system. Okay, making a predictive system. Okay, input data. So in this array called as input data, we need to give all those medical information, that is the glucose level, insulin, etc. Okay, so this will be input data. So we will fill this data later. Now we have to change this input data to numpy array. Say for example, let's get some data. So I have this data set here. Let me open this. Okay, so let me open this in notepad. So we need to give these medical informations, and the model has to predict whether the label is 0 or 1. Okay, so 1 represents diabetic patients and 0 represents non-diabetic patients. So let's just select a random example. Okay, so I'll just select this row. So as you can see here, the label for this particular data point is 0. Okay, so you can see the headers here. So the last value represents the outcome. So here the outcome is 0, which represents the person is non-diabetic. Okay, so we are not including this data. So we are taking all these data and we will feed this data to our machine learning model, and it needs to predict that the outcome will be 0, and which represents the patient is non-diabetic. Okay, so I'll copy this value and paste it here. So I'll be pasting this value in this input data. Okay, now I'll change this input data to a numpy array. So this basically is a list. Okay, so list data type, and we are going to change this to a numpy array because the processing on numpy array is more easy and efficient. So we are going to change. So changing the input data to a numpy array. So we have already imported numpy as np as numpy array. Okay. Input data as numpy array. So you can follow this same procedure for different projects where you want to make a predictive system. Okay, so this is just like a blueprint. So this will remain almost the same for different predictive systems. So input data as numpy array. np.asArray. So this function asArray will convert this list to an array. So np.asArray. So we need to mention this list name, so which is input data. So I'm pasting this here. So this will convert this data to a numpy array. Now we need to reshape this data. So reshape the array as we are predicting for one instance. So what is the reason for this reshaping? Okay, so our model is trained on 768 examples, right? So our model is trained on 768 example, and there are totally 8 columns in our model training. But in this case, we are just using one data point. If we don't reshape the array, what the model expects is it expects 768 data points or 768 values, but we are just giving one. So this will make a confusion to the model, and hence we need to reshape the array. And this reshape will tell the model that we are just going to need the prediction for only one data point. So that is the reason for this. So let me create the numpy array named as input data reshaped is equal to input data as numpy array. So we cannot do this reshape in list much, so that's why we are using numpy array. So it's more easy to do the reshaping in a numpy array. So reshape is the function we are going to use for this. So this reshape function belongs to the library numpy. Okay, so reshape 1 comma minus 1. So this is the parameter for this reshaping. So this will tell the model that we are not giving 768 examples, but we are just trying to predict the label for only one instance. Okay, so this will reshape the array. Now there is one more important thing. We cannot give this values as such. Why? Because while training our model, we have standardized the data, so we haven't used the raw data as such. Now what we have to do is we have to do the same procedure here, because if we give this data as such, our model cannot make predictions correctly. So we need to standardize the data in the same manner as we standardize our training data. Okay, so we have already fitted this to this x, which is the training data, and we need to use the same function scalar here. So you don't have to fit it again, you just need to transform it based on this scalar. Okay, so you can do that by, okay, so I'll make a comment, standardize the input data. Okay, let me make a variable called as standard data, std data is equal to, so we have already made the function scalar. So scalar dot transform input data reshape. So we need to transform this data and store it in the array called as standard data. Okay, now we can feed this standardized data to make the predictions. Okay, let me print this standard data as well. Print std data. Now let's make the prediction. Prediction is equal to, so we have made the machine learning model. So we have trained the model and we have stored it in the variable called as classifier. So this classifier has the trained support vector machine model. So we need to use that that variable classifier. So classifier, and for predicting we need to use the function predict. So classifier dot predict standard data. Okay, so we are standardizing the data and we are feeding the standardized data to our machine learning model. So you can note here that we haven't included the label here. So the model has to predict the label correctly. So prediction is equal to classifier dot predict standard data, and I'll also print the prediction. Okay. Now the model has to predict that the person is non-diabetic, because we have taken the example for a non-diabetic case. So you can see the label here 0. So I have to call the values here. Now the model has to give the label as 0, right? So let's try to print this prediction. So I am printing the prediction here. So you can run this. Okay, so module name numpy as array. Okay, so I made a spelling mistake here. Okay, sorry again. Okay, so this first two line represents our standardized data. Okay, so this is the data we are giving, and this data is standardized based on our standard scalar function, and this is the standard value. So you can see here it is almost in the same range, and this value is fed to our trained machine learning model, which is stored in the variable called as classifier, and we are predicting the label for this standardized data, and we got the prediction from the model as 0. So you can check here that we took the values for 0, which is non-diabetic case, and our model has predicted correctly the label for this data. So this is how you can use machine learning to predict whether that person is diabetic or non-diabetic. Let's do one more thing here. Let's say that if this value is a 0, we need to print that the person is non-diabetic. If the label here is 1, we need to say that that person is diabetic. Okay, so we can use a simple if statement there. So if prediction, so this prediction value is stored in the variable called as prediction, right? So this is that prediction value, and it is stored in a list. Okay, so if prediction is equal to, okay, if this prediction value prediction 0 is equal to 0, then we need to say that print the person is not diabetic, else the other cases the person is diabetic if this value is not 0. So in the other case the value will be 1, right? So else we need to print the person is diabetic. Okay, so now why I'm mentioning this prediction and 0? Okay, so basically this prediction is a list, so it doesn't give an integer value but it give a list, and this list has only one element. Okay, so that's why I'm mentioning this 0. So prediction, and if I mention the name of this list and mention 0 in this prediction, it means I want the first value. Okay, so the first value here is 0, right? So if the first value in the list prediction is 0, then we need to print that the person is not diabetic. Okay, otherwise we need to print that the person is diabetic. Okay, so the important point to note here is the output we are getting from our machine learning model, that is classifier, will be a list and not an integer. It doesn't print that either 0 or 1, but it prints 0 or 1 inside a list. So this is a list because it's surrounded by this square brackets, right? So we need to mention the index of this value. So the index is given by 0. So if the first element inside this particular list or set is 0, that person is not diabetic, otherwise the person is diabetic. Okay, so we have already took the example for this non-diabetic case. Once again try to run this. So the value is 0. So as you can see here, we are getting the output as the person is not diabetic. Okay, now let's try this for diabetic case as well. Let's again take some random values. Okay, so I'll take this value 5166. So you can see here, in this case the label is 1, that means the person is definitely diabetic. Okay, now it should give the prediction as 1, and it should say that the person is of course diabetic. Okay, so I'll just change this value and give this new value. So this should predict that the label is 1 and the person is diabetic. Let's see whether it's predicting correctly. So as you can see here, it has predicted correctly for both diabetic and non-diabetic cases. So this is how you can make a predictive systems that can just predict the label with the given input data. Okay, so this is the agenda we wanted to do for this video, and we have successfully completed it. So let me give you a short quick recap. So first of all, we have imported all the dependencies. So we have imported numpy for making numpy arrays, pandas for creating the data frame, and we have the standard scalar function to standardize the data, and then we add a train test split to split our data into training and test data, and we have imported the support vector machine model from sklearn, and then we have imported this accuracy score for finding the for basically evaluating our model. Then we have loaded our data set, which was in a CSV file, to a pandas data frame, and we have named the data frame to diabetes data set. So once we add that, we just try to see the first 5 rows to understand about the data in this data set, and then we have found the number of rows and columns in this data set, and we have found some statistical measures like mean, standard deviation, percentage, etc. Okay, then we have counted the number of values for diabetic cases and non-diabetic cases, and here the label 0 represents the person with who doesn't have diabetes, and 1 represents those who have diabetes. Okay, so and then we have grouped the data based on 0 and 1. So we have found the mean values for patients with diabetes and non-diabetes. Okay, so we found that there was a difference in their glucose level. So basically the glucose level is more for the patient with diabetes, and the age is also more for people who have diabetes. So it's one of the important insights we get from this data. And then we have splitted the data and the labels separately, and one of the most important step we have done is standardizing all this data, because all this data was in different range. So we have standardized the data to have a common range between them. So once we have standardized the data, we have splitted the data into training data and test data. So we took 20% of our data as test data, and then we have loaded our model support vector machine classifier into the variable classifier, and we have trained our machine learning model with the help of xtrain and their respective labels by train. So once we have trained the model, we have found the accuracy score on both the training data and the test data. Once we have a good accuracy score, we made a predictive system that can predict whether a person has diabetes or not with the help of this input data. Okay, so in this we have reshaped the array to tell the machine learning model that we are just trying to predict the output of only one instance, and then we try to print this prediction, and we just make a simple if statement that if this label is 1, we need to print that the person is diabetic. If the label is 0, then the person is non-diabetic. Okay, so we have successfully did this use case. So if you are just watching this video, it's not going to help you much, so I suggest you practice all these codes by yourself. Okay, so I'll give the link for this collab file in the description of this video, so you can download it, and from Google Drive you can open it through Google Collaborative. Okay, so if you have any doubts, you can tell me in the comments, so you can subscribe for more related videos. So this use case or project video will be uploaded on every Friday evening, and the basic machine learnings will be uploaded on Monday and Wednesday evening. Okay, so thanks for watching.